In this section, we will solve systems of equations algebraically. We will use the addition method. It's also called the elimination method. In this method, our goal is to eliminate one variable and then solve for the remaining variable. We will do that by matching the coefficients of either x or y in both equations. Let's look at the equation. We will decide which one is easier. Is it easier to match the coefficients of x or y? By matching, we mean that we would like them to have the same coefficients, but with opposite signs, so that when we add them, since they have opposite sign, they will cancel out. We try to choose the variable that can be matched easier. So in this case, 4 and 6, their least common multiple is 12, so it is easier. If you would like to match the coefficients of y, you would need to deal with larger numbers. So we choose to match the coefficients of x. Their least common multiple is 12. It is the smallest number that we can match the coefficients. For the first equation, we would like to make the coefficient negative 12. And in the second one, we will make it positive 12 so that they will cancel out. So we take the first equation and multiply by negative 3, so that negative 3 times 4x will be negative 12x, negative 3 times 5y will be negative 15y, and on the right side, negative 3 times 24 will be negative 72. And we take the second equation and we multiply the whole equation by positive 2. So we have 2 times 6x is 12x, 2 times 7y is 14y, and on the right side we have 68. Instead of the original equations, we take these modified equations and add. So just add term by term. Negative 12x plus 12x cancels out. So we only have y terms. Negative 15y plus 14y, we get negative y. And on the right side, we get negative 4. And we find y to be positive 4 by dividing both sides by negative y.